Okay, in this video, I'd like to talk to you a little bit about the sun's energy source that sort of occurs in the core. So where does all this energy and heat and light and bad stuff come from that we're talking about? Well, the real reason that the sun produces energy is due to a process called fusion. And what fusion is now is fusion is when two hydrogen nuclei come together. Okay, so right off you can see that it is going to be a nuclear process that involves the nucleus of atoms. So probably a quick review of atoms right here. Some of this you may know, but it doesn't hurt just to get the terminology out. About the first thing you know about atoms and maybe all of matter is that there's two types of charges. There's positive and negative, okay? Positive, I guess, and negative. Usually the positive charges are carried in things called protons or positrons, although the protons are sort of the more stable ones that we're probably more used to hearing about. But positrons, believe it or not, will come up in the context of the sun. The negative charges are typically carried in electrons, and so those are the two types of charges. And the second thing that's kind of important that you probably know is that opposites will attract each other. That means if I have a positive charge here and a negative charge sitting here, they will sort of start moving towards each other until if they hit each other, it'll just be like a poof, and you will get some light coming out. Okay, that can happen. If in the case this is a positron and this is an electron. Okay, so that's number two. Alrighty, and of course maybe the 2A, that might be 2A. And in 2B, you might say the other one is that likes definitely repel each other. And that'll be more relevant to us here when we start talking about the fusion, that the likes repel each other. What am I talking about? Well, if you have two positives here, a positive and positive, then generally they want to get away from each other. They're going to repel each other. Likewise, if you have two negatives, they are also going to want to repel one another. Okay, that's what we mean by likes repel. So literally, in this case here, a force will develop between the two opposites to pull them together. And in this case here, a force will develop between the two like charges to repel them, to push them away. Okay, and so maybe the next thing to review, point number 3 right here, is with these positive negatives, we have these things called atoms. Okay, and I suppose that if you would want the best view of an atom for this class, here's to think of the positive charge, or I'll just say a proton. Let's just start calling maybe the proton with a little symbol P right here, maybe an electron with an E right there, and the positron I think might be a P plus. We'll sort of talk about that as we go. But in either case, back to the atoms over here. The positron, the protons will be at the center of an atom, as you can see here. And the electron will sort of be out there orbiting. There'll be an electron right here. And it orbits around the proton, a lot like the moon orbits around the Earth, as we've been saying. Although this is not 100% the absolute correct picture, but it's good enough for us. That's what an atom would be. Okay, and the other thing that could appear in an atom, well, let me just label a few things here, and I'll tell you about that other thing. Where the proton is here, of course, that's called the nucleus here, and the electron is sort of out there maybe in something called an orbital or an orbit. So it sounds very similar to some of the planetary and the moon systems we've been discussing. But there's one more thing. The other thing that can appear in a nucleus then can be a particle like this that I'll put a little n in, and that is a neutron in there. And a neutron, the reason where the word comes from is they actually have no charge on them. So they are neutral. So they don't suffer any of these attraction or repulsive forces the way that two positive charges, two negative charges can. So with that, that is your first sort of review there about a little bit of atomic physics then, and some things that we need for the class here as we'll go talk about the sun's energy source, which is fusion here. But just a couple more points here. It turns out that the number of protons, that basically IDs the atom. For sure, that is the number one signature of an atom. And like if we, for example, wanted to come up with a little table here, we'll say atom here and the number of protons that you'd get, something like this. Well, if the atom is called hydrogen, then it has 1 proton in its nucleus. If it's called helium, then it has 2 protons in its nucleus. And so the easiest way to continue this chart here is, of course, to go to look at a periodic table of the elements, which you're probably used to seeing also. So I can go look at one of those. And you can see that it's sort of labeled in that structure that you're probably familiar with. And now these can have varying numbers of numbers in all the little boxes of the elements. But of course, what you see here is what we sort of said. Hydrogen has 1 proton in it. And if you scoot all the way over here to the next simplest atom, helium, it has 2 protons in it. And by in it, I mean down there in the nucleus, lithium S3, beryllium S4. And so maybe we'll put carbon with 6, oxygen 8, a few things like that, silicon 14, and you can just go on and on. But maybe I'll just add a few more items to the chart. But that's generally the map we have for how many protons are in a particular atom, keeping in mind once again that the number of protons uniquely identifies an atom. So if it has 8 protons in the nucleus, it must be oxygen, that kind of thing. Okay, so we can just go and put that in here. Here's your oxygen with 8, and maybe your carbon has 6, and so on and so forth. Okay, so we'll leave it at that just for a minute here, but that's just sort of your review here of atoms, and you probably remember that sort of thing from high school chemistry or a physical science class you took, something like that. Okay, and so that's about it. I think with some of the concepts that we just said here, you're good enough to maybe learn a little bit about what generates that energy in the sun.